Okay, hyperbolas, not hyperbole, not hyperbolas, hyperbolas. First equation's good, second equation is wrong. So just mark it out. And I'll put the other equation up here, and that will provide us a good starting point to talk about the two different equations. So y minus k squared over a squared minus x minus h squared over b squared equals 1. That's the second equation.
That's wrong, right?
That's the correct equation. That's the correct equation. This one is not right. That is the...
Because A always has to be the...
Okay, so a couple of things. First, how is that different than the ellipse equation?
It's subtracting instead of adding.
It's subtracting instead of adding. Okay? So there's your difference between hyperbolas and ellipses. Okay, so the A and B thing, for ellipses, A was always bigger, and that's sort of what controlled whether it was, longer this way or longer this way. So for ellipses,
Do you use bigger?
for ellipses, what matters is not who's bigger, what matters is who's first. So for ellipses, the question is who's bigger. For hyperbolas, the question is who's first. And it's sort of rigged to work out maybe like you think it would work out. This hyperbola, if x is first, it has an x orientation. If the y term comes first, then it has an up and down orientation. So for ellipses, well, for both of them, you can say A controls the orientation, but that's kind of weird. I wouldn't phrase it that way. Whoever's bigger for the ellipse controls its orientation. For a hyperbola, whoever comes first controls the orientation. So if x is first, it has a left-right orientation. If y is first, it has an up and down orientation. HK is still the center. You'll still, again, this idea of not really worrying about who's what you call A and B. If it's under X, go that many in X. If it's under Y, go that many in Y. So look at number 1. My center would be at McKenna. What's the center of number 1A there? It's just like circles and just like ellipses. Negative 1, 3. So let's go to negative 1, 3. And even though we've never graphed a hyperbola before, I bet Jace can tell us how many to go left and right.
3 and 5.
Well, careful, I said how many left and right. So go with your first answer of 3, because 3 squared is under the x. So let's go left and right 3. 2, 3. Michael, how many up and down should we go?
5.
Yes. So 3 and 5, so we'll go up and down 5. Okay, before you get too excited, like this is not an ellipse, so I'm not going to put the oval in there. This minus sign is, again, everything today is a hyperbola, but once we need to distinguish between the two, that minus sign is what makes it a hyperbola rather than an ellipse. Okay, so things get a little bit weird here for graphing purposes. Let's see, so we did the center, and then we did up, down, left, right stuff. Now we're going to make a box and asymptotes. I know, like, what? Box and asymptotes. We're going to make a box with those points. Those points are the midpoints of the sides of the box. So we draw in a box using those points. So we get the points the same way as an ellipse, and then basically our comparison with the ellipse sort of stops because this is not an ellipse. The asymptotes go through the corners of the box. This is why we make the box. The only reason we make the box is because that box helps us draw the asymptotes. So a straight edge is helpful. Your ID, you probably don't have a popsicle stick on you. So there's my asymptotes. And after that, we can sketch in the hyperbola. We didn't say this earlier, but is this a left-right hyperbola or an up-and-down hyperbola? How'd you know it was left-right? X came first. So these 2 points are the vertices. The left-right points are vertices. The other 2 points are not vertices. They're just helpers for the box. So I'm going to sketch in my hyperbola. Again, I've got 1 point and I've got asymptotes, so that's good enough. So those are kind of fun to draw. It's the Spider-Man spiderweb kind of thing. All right, let's try part B. Emma, how about the center? Oh, gotcha. Slow down and rethink that answer. Yes. But the mistake she made is a very common mistake because you get used to just putting them in order. And that works with circles and ellipses. But we got y first, so be careful. The center is at -1, 4. Gabby, how far up and down should we go? Good, 4 up and 4 down, because 4 squared's under the y. Again, I don't really care who's A and who's B right now. It doesn't really matter. If it's under x, go that many in x. If it's under y, go that many in y. Speaking of, Evan, how many left and right should we go? 6. So we'll go left and right 6. Okay, make sure you're paying attention. This is not an ellipse, it's hyperbola. So instead of drawing in the circle and being done, we've got to do the box and the asymptotes. Some people use different colors for the box and the points and the asymptotes and the hyperbola and get this very colorful graph. So there's the box. The asymptotes go through the center and through the corners of the box. Asymptotes go through the center and through the corners of the box. And then lastly, Naomi, is this a up and down hyperbola or a left and right hyperbola? Up and down. How did you know that? Because y is first. So my up and down points are my vertices. Those 2 left and right points were just like helpers for the asymptotes. So this one is a very wide hyperbola. All right, do we need to do the third one, or are we okay? What's the center of the third one? That's the main thing. The origin. We'd go left and right 3 and up and down 3. So the box would be a square. Is it a left-right hyperbola or an up-down hyperbola? left, right. So that's enough for that third one. The vertices of the hyperbola are the points on the box that are on the graph. I tried to say that, but on the box, on the graph. The other two are not officially vertices. Sometimes we kind of slip up and call them vertices because we graph them all the same way. But officially, the only two vertices are the ones that are on the graph, on the box. So in 1A, that would be those 2 points on the graph, on the box. Goodness, so that is negative 1, 2, 3, 4, comma, up 3, and over 2, up 3. And the vertices for 1B would be those 2 points. So that's negative 1, 0, and negative 1, up 8. By the way, we almost always use 10 by 10 graphs. So if you're 2 away from the edge, you're at 8. You can save your time from counting all the way out there. All right, number 4. Given that hyperbola, Justin, what about the center? Okay. I think before we answer the vertices question, we should probably think about, is this left, right, or up, down? Left, right. So you could write that, or sometimes I'll just do a quick little sketch to make sure my brain is thinking that way. So to get to the vertices, Cade, which way? Excuse me. My sneeze makes it on the video. Cade, which way should I go to get to the vertices? Am I going left and right or up and down?
Left and right.
Left and right. And how many left and right should I go? 8. So I'm going to go left and right 8. This is a little reminiscent of the foci from yesterday. So if I want to go left and right, which coordinate should I adjust? The x. So 6 plus or minus 8 to accomplish the left and right 8, comma, negative 9. And I'm okay if you leave it like that, because to me that really emphasizes that you're going left and right from the center. Now if it's multiple choice, maybe we spell them out and you've got to do 6 plus 8 is 14 and 6 minus 8 is negative 2. But if it's a free response and you want to leave it with the plus or minus, that is okay with me. If you'd rather spell them out, that's also okay. Okay, so that's all number 4 asked. We didn't have to graph it or asymptotes or anything like that. Number 5. Leah, how about the center for number 5?
0, 11.
Very nice. We let Emma take the hit earlier, and now no one else will make the mistake. That's okay. 0, 11. Mariana, where are my vertices relative to my center? Yeah, where are my vertices relative to my center? Meaning, are they up and down or left and right?
Up and down.
How did you know that? Because y is first. So maybe even a very crude sketch of the hyperbola might help us think about that. Danny, we said up and down, so how far up and down?
9.
Up and down 9. So 0, comma, up and down would be the y coordinate. Up and down 9. And again, all the same things. You can leave it like that, or you can do 11 plus 9 is 20, and 11 minus 9 is 2. Okay, like ellipses, hyperbolas have two foci. The two foci lie inside the curves. So the foci, whether it's an ellipse or a hyperbola, the graphs always wrap around the foci. That was true of parabolas as well. We're not doing them, but they wrapped around their focus. Ellipses wrap around their focus. Hyperbolas wrap around their focus. This definition is similar to the ellipse definition. For the ellipse definition, it was the sum of the distance from the focus to a point. For a hyperbola, it's the difference. This is tricky. So that difference from D2 to D1, any point I pick, that difference is a constant. So if I come way over here and again do D2 and D1, D1 minus D2, if the absolute value of it is a constant. That's kind of tricky. We don't really make use of that. There's the definition. The set of all points where the difference of distances from two fixed points is constant. I feel like that's a harder one to figure out or think about than the ellipse one. C squared. To find the foci for a hyperbola, C squared equals A squared plus B squared. So is that good news or bad news, I guess? I mean, in terms of remembering that. How does it compare to the ellipse? Is it the exact same as the ellipse? The opposite. Okay, so the ellipse had a plus in the main formula, but a minus for the foci. Hyperbola has a minus in the main formula, but a plus in the main foci. So from ellipse to hyperbola, you're switching signs, both in the main equation and to find the foci. Now, the good news is if you get it backwards and you do minus, your foci are going to end up not where they need to be. So you've got to use plus to get them into the foci. And again, it's the distance from C is the distance from center to foci on the it's not really the main, it's not the long axis, it's not the major axis. I'm just going to call it the main axis. Like whichever one comes first. That's the one that matters. Again, ellipses bigger means more, hyperbola first means more. All right, number 5. Find the foci of the hyperbola with that equation. Jacob, you with us over there? Sort of?
Find the hyperbola.
Well, let's start by finding the center. We'll give you an easy one.
Okay, we'll find the center. I don't know, -3, 1.
Yes. -3, 1. Ethan, I want to find the foci, but where are they relative to the center? Are they like left and right, or are they up and down? They're left and right. How did you know that? It's first. X is first. We don't really care which one's bigger. The foci are left and right of center because X is first. Okay, so C squared equals A squared plus B squared. Now it really doesn't matter which one's A and which one's B because we're adding them. A is first, but it doesn't matter. We're adding them. Oh, kind. 36 plus 64 is 100. So C is 10. So our foci left and right, so I need to adjust the X coordinates by 10 either way, and then Y is still 1. I already made them. Thank you. Quiz copies. I'm glad you said that. Maybe tomorrow would be a good day for a quiz.
No, you're
No, you're
I think it would be a good day because they're already made.
Is it a group quiz?
Number 6. Find the foci. Again, the foci, but let's back up.
Is it a group quiz?
I don't know. That's a long time from now. Macy, how about the center of that?
-8, 5.
Good. -8, 5. Dia, where are my foci relative to the center?
Up and down.
Up and down. Again, this is not something you need to write down, but it's certainly something you need to think about. So whether you write it or not, that's up to you. Or maybe you don't write it that way. Maybe you just do a quick little sketch. Like, I don't know what it looks like, but it's definitely an up and down hyperbola. So I know the foci have to be up and down from the center. Speaking of up and down, how many up and down from the center should we go, Addie?
Up and down,
We should go 3. So that would be -8, comma, adjust the y value up and down 3. Whoops, that's not right. That would be the vertices. Well, you did it wrong, but I kind of led you down the wrong path, so I'll take credit for that. You can put that one on me. I need to find C to get to the foci. So see how I fixed my error by just relabeling that the vertices there? That would be the vertices. I would go up and down 3. But to get to the focus, I need to find C. I got to do a squared plus b squared. Again, we're adding, so it doesn't matter who's who. 45. So that would be 3 square root 5. Okay, and then I'm going to adjust. So I did the right thing and just did it with the wrong number. I'm going to adjust the y coordinate by 3 square root 5 to get the focus. So -8, comma 5, plus or minus 3 square root 5. To make further use of my error here, make it look like I meant to do this, 3 square root 5 is bigger than 3, so that sort of emphasizes that the focus, the foci, are farther away than the vertices. Yeah, it's that picture too small to label everything, but the vertices are on the graph, the foci are farther away. I bet you already know what we're going to have to do with number 7. I mean, we're going to graph it, but before I graph it, I'm going to have to complete the square. And factor out a 9 and collect, yeah, it's 9x squared plus 36x minus 4y squared minus 32y equals 64. So sort of the same setup as an ellipse. Collect the x stuff, collect the y stuff, get the other number out of the way. What do we do next on ellipses? Or what? Take out the 9. So x squared plus 4x. What do you want to take out over here? -4. Take the negative out. And then be careful, because if you took the negative out, that becomes positive 8y. And now we can switch to completing the square. Let's see, b over 2 is 2. Half it squared, add it to what we're doing here. Squared is 4. But I really added 36. Alright, I wrote plus 4, but I added 36 because of the 9. b over 2 is 4. 4 squared is 16. So what do I need to put on the other side to balance that plus 16 that I wrote? -64. right? 'Cause I wrote plus 16, but there was a negative 4 out front, so I really subtracted 64. Okay, so 9 times x plus 2 squared minus 4 times y plus 4 squared equals, so that was kind of nice over there, 36. Divide by 36. Clearly a rigged problem when everything reduces nice and neat. X plus 2 squared over 4 minus y plus 4 squared over 9 equals 1. Complete the square. Oh, it does want us to graph it. Jonathan, where's the center going to be?
Center is going to be at -2, -4.
I like that. -2, -4. Sophia, super open-ended question. What should we do next?
Find out if it goes up or down and left or right.
Okay, so which one does it do?
Up or down.
Which variable comes first?
Oh, I thought this which one was like larger on the bottom. And one's the bottom.
Larger on the bottom is an ellipse question. Who comes first is a hyperbola question.
Oh, because so it isn't right.
So it is going to be left and right. Now, even apart from which way it goes, we would still get the numbers right, I think. So, like, Katie, how far left and right should we go?
2.
And Dylan, how far up and down should we go? And Jameson, do you remember what we do next?
Make the box
Make-
and the asymptote.
Good, box and asymptotes. This is the chance to get all colorful if you want to use different colored pens or highlighters or whatever. And then lastly, Sophia already answered this. We're going left and right. So there's my left-right hyperbola that we had to use complete the square to get to. Worried about time. Do we need to do number 8? It's just another complete the square problem. So let's pass on number 8. We've done enough complete the square. Did you finish it? Did you get y minus 3 squared over 4 minus x minus 2 squared over 1? Well done. That is correct. So center, focus, all the things. Let's keep going to make sure we get to everything. Okay, interesting application of conic sections involves the orbits of comets. So yesterday we did orbits of planets, now we got orbits of comets. Of the 610 comets identified prior to 1970, I don't know where Miss Murray finds this stuff, 245 have elliptical orbits, 296 have parabolic orbits, 70 have hyperbolic orbits. I feel like, is that really an orbit though? I thought an orbit had to like make a, you know? You understand my question there? So maybe a path is maybe a better way to say it. Parabolic path, hyperbolic path. The center of the sun is a focus of each of these orbits, and each orbit has or paths if you prefer, each orbit has a vertex at the point where the comet is closest to the sun. Okay, so kind of a picture of what's going on there. Undoubtedly, there have been many comets with parabolic or hyperbolic orbits that were not identified, right? Because if it's flying way out there and it's a hyperbolic orbit, it's not coming back. It's just gone. So we don't worry about those. Okay, so here we go, the idea of the orbit. We only get to see those comets once, right? Because they don't come back around. So again, is the use of the orbit word correct? I don't know. Comets with elliptical orbits, they do come around. Halley's Comet is 70-something years, I think. I don't remember. Eccentricity. As with ellipses, the eccentricity is still E equals C over A. So that's good. The formula is the same for eccentricity. It's still C over A. But because C is bigger, right, the foci are farther away than the vertices, then C is bigger than A, so E is bigger than 1. Maybe a picture. So center to vertex, that's A. Center to focus, that's C. So for a hyperbola, C is bigger than A, so E is bigger than 1. So the hyperbola would look something like that. They wrap around their focus. When the eccentricity is large, the branches of the hyperbola are nearly flat, close to parallel lines. When the eccentricity is close to 1, it's more narrow. So narrow with 1 big eccentricity is flatter, almost parallel lines. Number 9, find the eccentricity, E equals C over A, of that hyperbola. Simplify your answer. Okay, now it does matter who's A and who's B. But for ellipse, A was bigger. For hyperbola, A is first. For ellipse, who's bigger matters more. For hyperbola, who's first matters more. So what's A for this problem? Well, careful, square root of 24. A squared is 24. So A would be 2 square root 6. I still need C. C squared equals A squared plus B squared. So that's 54. Square root of 54 is 9 times 6, or 3 square root 6. Oh, that was kind of cute what they did there. Because C over A is 3 root 6 over 2 root 6, also known as 3 halves. And you're not going to have to know, okay, that's 1.5. So I know it's bigger than 1, but like how narrow or how flat, like, I don't know. That seems close to 1, so maybe more narrow. Number 10. State the equation of the hyperbola in standard form, then determine everything. Looking at that picture, what do you think we should find first? Center. So it looks like it's on this line. And right in between 5 and -1 would be 2. So my center is at 2, -2. Which things come in first in the equation? X's or Y's? X. Why is X coming first? Because it's left and right. So maybe I should have answered that first. I know what this thing's going to look like. Right? Like X comes first, so it's got to look like that. So I can go ahead and do X minus 2 and Y plus 2, because I know where the center is. Somebody was saying what number's going under X? Yeah, the vertices are 3 away, so 9 will go under X. And I kind of don't like this next part. I mean, I guess it'll work. I'm gonna use a ruler and see if I can figure out the, like, because I don't know where the other side of the box is, right? Like, but maybe I could kind of guesstimate it. So it's got to be, my asymptote has to go through the center, and then my asymptotes need to be, trying to make this work to be a nice one. Let's make it go through. So you're not going to have one of these on the test because like you'd be guessing, and we might come up with slightly different values. But I'm going to say it goes through like up 3 over 4. Or right 3 and down 4. Because, yeah, I don't like this problem, because how are you supposed to know that? I mean, are we expecting you to sketch in a perfect asymptote? And the answer is yes. Yes, we are. For this problem. You will not have one like this on the test or the quiz. So that means we went up and down 4 to make that box. Yeah, I don't like that because we are not going to ask you to guess the location of the asymptote. We'd probably just put the asymptote on there so you could figure out where the box is. So that distance is 4, so 16 under the y stuff. Okay, so there's the equation, but it looks like there's more to do here. Then determine its eccentricity. C over A. Yeah, we'll get to the asymptote equation in a minute. That'll be not really that hard once we get there. A is 3. B is 4. C squared equals A squared plus B squared. That's, again, hyperbola is minus on the main equation, but plus on the C equation. Another one that works out. 9 plus 16 is 25. So eccentricity is 5/3. Check that one off. Foci are C away, so I'm using C. Where are my foci relative to my center? What was that question, Dia?
Why don't you say plus or minus?
Well, I know my eccentricity's got to be bigger than 1. That's one answer to it. If you are thinking plus or minus 5, that's not a bad thing to think because we are going to go left and right 5, but we would still just say C is 5. Now, you're right. If this was some random math equation just, sitting out on the green belt, and you walked up on that, you would take off 2 points for this person because they didn't put plus or minus. But in the context of a hyperbola, we just want to use the positive one. So it's a good question. We said focus are left and right because it's a left and right problem. So I'm going to go 2 and then plus or minus 5, comma negative 2. I suppose I could put them on the graph. It didn't say to graph them, but left and right 5. If you want to sort of visualize where they are. It wraps around the foci.
Do you have to do the math to find the foci, or can you just look at
Right, you can't just, maybe if you were like, you've done 100 of these, you could eyeball where the foci are, but you'd have to do the math. What's left? Asymptote equations. Let's first remember the point slope form of a line, because that's going to be our friend again. we can save some time here if we pick a good point that is on both asymptotes. Maybe we could write both asymptotes with one equation. Definitely the point 2, -2 is on both equations, or both asymptotes. So y plus 2 and x minus 2. What about the two slopes? You just look at the picture. Slope is change in y over change in x. So one of them's a positive 4/3, and the other one's a negative 4/3. So again, if we're smart, we can catch both asymptotes with, I shouldn't say one equation, that's still two equations, one expression, one line that gets both asymptotes. And that's it. So you think writing an equation of an asymptote would be hard, but it's really easy if you use the center as kind of that key point, because they both go through the center.
Why is the slope?
The slope is always the change in y over change in x. And you're going to get to the point where you don't need to do any of that. You can come back here and say, well, change in y was 4, because 4 squared is under y. And change in x is 3. So my slopes are plus or minus 4/3. So after you do a couple of these, you can writing the asymptote is in some ways the easiest part of all of it, because it's that y plus 2 and x minus 2, and just make sure you do y over x. Jonathan?
Is point slope form a safe stop with x?
Definitely. We like point slope form. Yes. Yes, that's a pre-calculus thing, because we use that form in calculus. I shouldn't say exclusively, but almost exclusively. Okay, do we need to do number 11? It's another one where we play guess the asymptote. So x plus 4 squared. Whoops, but the y thing has to come first. Y minus 4 squared. Oh, yeah. So that part's easy. There's one more easy part to put or to do. What else is easy about this problem? Yeah, the up and down, so 2 squared is 4 under the y. But then, again, we are not going to force you to play guess the hyperbola. It's a new game show. And I think I hit it just right there. To make that box. 1, 2, 3, 4, 5. Yeah, I don't like guess the hyperbola. I mean, guess the asymptotes. Let's jump ahead and do the asymptote equation without finding anything else. Again, if you know what the form should look like, and you know it goes through the center, then you can use y minus 4 and x plus 4. And what will the slope be? Again, make sure you do y over x. Slope will be 2/5. I mean, it's on the picture as well. So there's my asymptote equation. I'm going to pass on doing all the other stuff. Eccentricity is c over a. Foci are c away. Where are the foci? Left, right, or up, down from the center? up and down, because it's got to wrap around the foci. So I don't know where they are, but they're somewhere on like that axis, the foci. Okay, so whatever worksheet is next. Worksheet 3? Question mark? I think so. Is the next assignment. Yes, quiz tomorrow. Yes, I'll give you some time to work together on it. And it covers the 3 things that we've done. Circles, ellipses, hyperbolas. So I'll answer questions first, then we'll do the quiz, and then we'll do the new thing for tomorrow. But I don't think the new thing is going to take very long tomorrow. In fact, you already know everything you need to know to do tomorrow's lesson. It's just kind of putting it all together. So tomorrow we have plenty of time to answer questions, do a quiz, and do the lesson, and probably still finish the homework before you leave. All in a day's work. And tomorrow will be the last day of new notes for the 9 weeks.